In this video, I'm going to talk through the first day problems for the Unit 2G review packet. So that's systems of linear equations. I'm going to talk through the day one. So I circled those in yellow. So for the first one, it says, tell whether the given ordered pair is a solution of the linear system. So I have to think through, well, what does it mean to be a solution of a system? For this point to be a solution for this system, it means that it has to satisfy both equations. So I can check that by substituting that in. So 3 times 4 plus negative 6, does that equal 6? That's what I'm trying to decide. So that'd be 12 minus 6. I want to know, does that equal 6? So 6 equals 6. Yeah, 6 is equal to 6. That satisfies the first equation, but I also have to check the second equation. So 4 plus 2 times negative 6. I want to know, does that equal 8? Well, that's really 4 minus 12. So that would be a negative 8 equals 8. And that is not a true statement. So these are not equal. So it does not satisfy the second equation. And in order to be a solution of the system, it has to satisfy both. So this would be no. That point is not a solution to the system. For number 2, it says draw the graph of a system of linear equation that has no solutions. Well, in my head, I'm thinking, well, how could a system of equations have no solutions? Well, in order for us to see the solutions on a graph, the solutions are going to be the points where the two lines intersect. So if there's no solutions, that means there's no point of intersection. So what that means is I'm going to have two lines that are parallel. So I'd come in here, and if I draw this line, I have to draw another line parallel to that. Now, because these two lines are parallel, there is no solution. Let's get you down to number 3. It says, without solving the system. So I can't actually solve it. It wants me to figure out how many solutions does it have. Well, if I don't solve the system, I mean, I'm not going to graph it. I'm not going to use substitution or elimination. I got to figure out how many solutions there are. So I can think through, well, if I envision a graph, remember back here, this had no solutions, and they were parallel lines. So I can think through, well, how can I know whether two lines are parallel or not? Well, if they're parallel, they're going to have the same slope and different y-intercepts. So if I get both of these in slope-intercept form, and I do that by dividing by negative 2, I can see that this equation becomes y equals, this would be a positive 3x minus 1. And when I do that, I recognize they're the exact same equation. So if I were to graph them, I'd have one graphed right on top of the other, which means that every point on the line would be a solution. So it says determine the number of solutions. Well, if every point on the line is a solution, that means there are infinitely many solutions. Because every point on the line, you'd graph the line, and then graph the other one right on top of it. Infinitely many solutions. Scooting down to number 5, it says solve the linear system by graphing. So I have two equations. This one is already in slope-intercept form, so I'm going to go ahead and graph this one first. Y-intercept of negative 4, slope of 2, that means rise 2, run 1. Or down to left 1. So this would be one equation. The other one is not in slope-intercept form yet. So, oh wait, yes it is. It's just y equals on the other side. So that's no big deal. I can just graph it. My y-intercept now is positive 3, slope of negative 1/3, which means I go down 1, right 3, or up 1, left 3 to graph the second line. And so when I do that, remember the point or the solution is going to be the point where they intersect, because the point where they intersect satisfies both equations. So that'd be the point 3, 2. So the solution would be 3, 2. And if I want to double check to make sure that is correct, I could use a graphing calculator. Oh, that one is dead. So in a graphing calculator, oh, this one is, oh no. All my graphing calculators have died, but you could check in the graphing calculator by looking at the table or substituting in to make sure those graphs are correct. All right, flipping to the back. Number 9, this says just solve for x. So I just have an equation. When it says solve for x, that means the final answer will be x equals. I'll have x all by itself. So I got to get x by itself, which means I need everything else to the other side. So I'm going to subtract 6y from both sides. I'll be left with 3x equals a negative 6y plus 12. I don't have x by itself yet. I have 3x, and that's 3 times x, so the inverse would be dividing by 3. And then I have x equals, that's a negative 2y plus 4. Now I've solved for x because x is all by itself. All right. Switching down to number 11, it says solve each system using any method. Now remember, there's multiple methods. We can use graphing, substitution, or elimination. Now there's no graph here, so I'm not going to solve this by graphing. So I'm either going to use substitution or elimination. And when I look at this, because I see one equation solved for one of the variables, I'm going to use substitution because it'll be easiest for me to substitute in. So I'm going to rewrite the second equation, but take out the y and replace it with negative 2x plus 6 because y is equivalent to negative 2x plus 6. So that becomes 10x plus 5. I'm going to substitute in with parentheses, so don't forget that, plus 6, and then finish that equation, equals negative 35. And now I just have to solve this equation to find what x is. So I distribute, I get 10x minus 10x plus 30 equals negative 35. 10x minus 10x is 0, so I'm just left with 30 equals negative 35. Well, what that means is the variable is gone. These two are not equal, so in this case, there is no solution. Meaning if I were to graph these two, they would never intersect. They'd be parallel lines. So here we have no solution. Switching down to number 13. Number 13, again, we can solve using any method. When I look at this, both of these equations are in standard form, so I'm thinking it might be easiest to solve with elimination. Now, it wouldn't be that bad to solve with substitution because the coefficient of x here is 1, so all I have to do is add 4y to both sides to get x by itself. But I'm going to do elimination because they're both in standard form. In order to eliminate, I need the coefficients of one of the variables to be opposites. So if this is a 2, that would have to be a negative 2. If that's a 5, that would have to be a negative 5. Or that would have to be a negative 4, or positive 4 to add to be 0 here. So as I'm looking at all my options, I'm thinking, well, if I multiply that bottom one by negative 2, now positive 2x and negative 2x will add to be 0. So I'm going to rewrite this. That one stays as it is. But this bottom one now becomes negative 2x plus 8y equals negative 18. So now when I add these vertically, these add to be 0. I'm left with 13y equals a negative 13. And now I need to solve for y. Divide both sides by 13. I get y equals a negative 1. I have not solved the system yet. All I found was the y coordinate. So I know that the solution will be something comma negative 1, but in order to find the x coordinate, I need to substitute that back into either one of these equations to find x. So let's just do the top equation, 2x plus 5 times negative 1 equals 5. So that's really 2x minus 5 equals 5. And so now as I solve for x, I see that 2x is equal to 10, or x is equal to 5. So that means the solution will be 5 comma negative 1. And I can check my answer by substituting these both in to the original equations. So they make sure they have to satisfy them. So looking back here on my calculator, I will do up here 2 times, well the x was 5, plus 5 times y was negative 1. And when I press enter, I want that to equal 5 if it satisfies that equation. And it does. And I can check the bottom one as well. So x will be 5 minus 4 times y was negative 1, negative 1. And this time when I press enter, I want it to equal 9 in order to satisfy that equation. And in fact, it does. So 5, negative 1 is the correct solution. Flipping to the back, number 14, it says solve using any method. Again, so the same idea. This one, again, because both of these equations are in standard form, meaning x, y, and then the equal sign, and our constant term on the right-hand side, I'm going to solve this by elimination. Now, this is a little trickier because I can't multiply negative 3 by anything to make it the opposite of 5, nor can I multiply either of these equations to make them the opposite. So what I'm going to have to do is multiply both equations by a number, by an integer, in order to make them opposites. So if I want to eliminate the x's, I could multiply the top one by 3, the bottom one by 5, and that would make 15x and negative 15x. Or I could multiply the top one by 7 and the bottom one by negative 2, and I'd have 14y and negative 14y. So since last time, what did we eliminate? We eliminated the x's. I'm going to go ahead and eliminate the y's this time, because you don't always have to eliminate the x's. So I'm going to multiply the top one by 7 and the bottom equation by negative 2. So when I do that, I'll just move that over here. We have 35x plus 14y equals, what would that be? Negative 18 times 7. Let's just double check this. 18 times 7 will give me 126. So this will be a negative 126. Over here, this would be a positive 6x minus 14y equals a negative 38. So now when I add these add to be 0. 35x plus 6x would be 41x. Over here, these would add to be, well, 128 plus 38 would be negative 164. And now when I divide by 41, I get 4. So this would be x equals a negative 4, because a negative divided by positive is a negative. Again, I know the x coordinate, so I know it's going to be negative 4 comma something, but I got to find the y coordinate. And so when I go back up here, I could use either equation. Oh, we can use the bottom one this time. Last time we used the top one. So negative 3 times, we found out the x was negative 4, plus 7y equals 19. Negative 3 times negative 4 is a positive 12. And so now as I start solving, I subtract 12 from both sides. I get 7y equals 7. Divide by 7 on both sides, I get y equals 1. So there's my y coordinate here. Again, to check my answers, let's just double check them in the calculator real quick. Back up here, 5 times, well, x is negative 4, plus 2 times y was 1. I press enter. I want that to equal 18 if it satisfies the equation, and it does. Down here, negative 3 times x was negative 4, plus 7 times y was 1. When I press enter, I want to equal positive 19 now to satisfy the equation, and it does, so I'm good to go. All right, looking back up here for number 16. It says set up a system of equations to represent each problem, and then solve and show all of your work. So Martha and Rachel are starting bakeries. Martha spent $140 on materials to start her business, and Rachel had coupons, so she only had to spend $90. So that's how much they each started with. Marcia sells her cakes for $20 each, and Rachel sells her for $15. So I underline these numbers, but let's color coordinate these. So we're going to say Martha is going to be in pink, and then I'm going to highlight everything to do with Rachel in blue. It'll help keep all these numbers straight for me. So write a system of equations that models the profit each woman earns. Now remember, your profit is how much you make minus how much you spend. So for Martha, she spent $140. So initially she's in the hole $140, meaning she's as a negative $140, but she earns $20 a cake. So her profit will be however much she makes selling her cakes. So 20 times the number of cakes she sells minus that initial cost. And for Rachel, she sells hers for $15 a piece, so 15 times the number of cakes, minus she only spent $90 starting up her business for the materials. We got to make sure we define these variables. Here, the y will equal the profit in dollars, and x here will be the number of cakes sold. If each woman sells 8 cakes, who earns a greater profit? Now, there's a couple of different ways to do this. You could just look at the equation and say, well, y equals 20. The number of cakes is represented by x, so times 8 minus 140. Martha then, what would that be? That would be 160 minus 140. If Martha sells 8 cakes, she gets $20. If Rachel sells 8 cakes, 15 times 8 minus 90. 15 times 8, well, 10 times 8 is 80. 5 times 8 is 40. So 80 plus 40 is 120. So she makes less money, but then she also spent less money initially. So this would be $30. So Rachel is the one that would earn a greater profit. Now, there's another way to do this. You could make a table. So let's make a table for these ladies. So we'll say M is Martha, R is Rachel, and X is the number of cakes. So if they sell 0 cakes, 1, 2, 3, 4, 5, 6, 7, 8. We'll make a table. So Martha originally had no money, or had negative 140. After selling one cake, she'll have a negative 120. After selling another one, negative 100, negative 80, negative 60, negative 40, negative 20. Now she broke even. And after 8, she now makes a profit. Over here, Rachel starts in the hole $90 after selling one cake. That's $15 less that she owes. So it'll be negative 75, then negative 50, then negative 35, then negative 20, negative 5, positive 10, positive 25, and positive... did I make a mistake somewhere? Here to here. Oh, yeah, this should be negative 60. This would be negative 45, negative 30, negative 15, 0. There we go, 15 and 30. I made a little mistake there in my math. But then we can see at 8, Rachel would have more money, more greater profit, I mean. All right, what point will they earn the same profit? Well, you could continue, excuse me, with the table and continue on, or you could set these two equal. 20x minus 140 equals 15x minus 90. Now to solve this, I'm going to get the x's on the same side. I have 5x minus 140 equals negative 90. I add 140 to both sides. I get 5x equals 50. So then when I divide by 5, I get x equals 5. So at what point will they earn the same amount of profit? When each sells 10 cakes. Ooh, not 5, that's 10. My bad. So when they each sell 10 cakes, they would have the same amount. And you could continue on in the table and find that point as well. All right, and flipping to the back. Last problem for day 1. It's number 19. It says for 18 and 19, label variables, set up a system of equations that can be used to answer the question, and then solve that system to answer the question. So we got to set up a system of equations. So you and your family are buying gifts for people in the military services overseas for the holidays. On Tuesday, all right, so everything that has to do with Tuesday, I'm going to underline in blue. So we got all that. And on Friday, we bought those guys, and it came up that much. So how much does a box of soap cost? That's what we're trying to find. Well, the question is going to help us write the equation because that's going to be part of what our variables are. When I look at Tuesday, an equation for Tuesday would be that 5 boxes of soap. So I'll say 5S plus 6 bags of candy, 6C, will be equal to $56.75. And then I can do something similar for Friday. On Friday, we had 8 boxes of soap plus 4 bags of candy, and that costs $60. So here's my system. And this S equals the cost of a box of soap, and C will equal the cost of a bag of candy. And now I can solve this system in order to answer the question. Here, because they're both in standard form, I'm going to use elimination. So I'm going to multiply the top equation by 8, and I'm going to multiply the bottom one by negative 5. And when I do that, I then have 40S plus 48C equals 454. The bottom equation becomes negative 40S minus 20C equals negative 300. And so now when I add these vertically, these add to be 0. I'm left with 28C is equal to 154. And when I divide by 28, I get that C is equal to 55. So this is the cost of a bag of candy. I want the cost of a box of soap. So I can substitute that back in. to either one of these equations, not 55, 5.5, sorry. 5.5 equals 56.75. And now I can solve this equation. Let's subtract 33. I get 5s equals 23.75. And when I divide by 5, I get that s, the cost of a box of soap, is 4.75. So the answer is a box of soap costs $4.75.